All right, interpreting graphs. If you look at these three graphs, they're all about the same data. Do you get how they give you different information? They look different, don't they? I mean, if your boss asked you to like say, hey, show me how our website's been doing over the last few months, and you gave them option 2 compared to option 1, which one's got better info? 1 or 2? Yes. Why 1? Has more detail. All right, good. I agree. And even though you could argue that option 2 looks cleaner, maybe easier to read, do you get how you'd be missing out? Like these spikes are kind of a big deal. For a person who runs a website, they really care about those spikes. I mean, 35,000 people visited in like one day. That's kind of a big deal. I actually have a website, and my 2-minute teacher site got a lot of press one time because we made it onto the news. Same idea, just a huge spike in people visiting, and that was really cool. 4,000 hits in one day. This is a bigger time website. There's sites that get 500,000 views every day. You know, this really depends on the site. But all right, so basically, you get a whole bunch more information from some graphs than others. All right, we're going to just talk about some simple stuff. If this is the number of people in the stadium versus the time since the game ended, is this the way people really walk out of a stadium? No. Would you generally agree that at the beginning here, at time, like right there, right when the game ended, that's time 0 since the game ended, and this is like time 1 hour after the game ended, that generally there's lots of people right when the game ends and then in the stadium, and there's pretty much nobody. It's gone almost to 0 by the time it's 1 hour later. There's pretty much everybody's gone. Does that make sense? All right, I want you to sketch what you think off to the side, make a different graph. What do you think it's more like in real life? Still needs to start high and end low, but make me a little sketch of what do you think happens more if you're talking about how many people are still in the stadium after the game. All right, I'm going to pause for a second and have a kid put their graph up on the screen here. Okay, I got two kids' graphs up here, and one person with the green graph was showing that basically people were running out of the stadium right at the beginning, and that's kind of true. Could you make the argument that the red graph actually happens? Why would what would that mean? Yes. All right. She said a lot of people are trying to leave at the same time, so doors are getting blocked, the aisles are crowded. I mean, it's really hard to get out fast at the very beginning. So after the very big, kind of like the very beginning where there's a clog, then people kind of start flowing better. Does that make sense? Could make that argument at least. All right. Okay, you guys that are mirrored up there, unmirror yourself. Awesome. Now, let's go on to this one. Independent versus dependent graphs. All right, what is independent? Well, if you're independent, that means you really don't need anybody else. You don't depend on anybody else. Okay, you guys are kind of in between at this point in this age in your life. Do you agree that you could probably survive without your parents, without a house? Okay. So some of you are going to be more likely to say, yeah, I'm completely independent, I'd be fine. And others would be like, all depends on, if you think, would you survive? Yes. Would you thrive? Probably not. But, there's a lot of kids at your age that are already on the street. And so you could probably survive. Wouldn't be a very fun life right now. Be more fun if you waited until the normal time when you kind of leave the house, okay? In some countries, you guys would be old enough to be on your own from your parents, doing your own job, and some of you would already be married and having kids. I know it seems crazy, but in this country, it's different than in some other countries. So, all right, independent means like you don't need anybody else. You don't depend on the other person. Of these two things, time and money, which one depends more on things, and which one doesn't depend on things? What do you think?
Money depends on time.
All right, so money is dependent more, you're saying, and time is independent. Would you agree? All right. Those are the two that kind of are the most important two that I use, because money is the ultimate dependent thing. I'll give you an example. How much does a glass of water cost? What's the right answer? Depends. See? It's dependent. So a glass of water like poured out of a bottle, you can actually spend like $5 for a bottle of water if you're in the right spot or the wrong spot, you might say. And on the other hand, time, does that ever depend on anything? Well, wait, we're going to make time stop for a minute here. You can't. Time doesn't.
Keep on ticking.
Yep, it doesn't depend on anything. All right. So if you have time involved in your graph, you better put it on the bottom. That's why it's always been there, is because it's independent. Okay? So if we're talking about which one depends on which one, look at this slide. I want you to circle the one, and it actually says which is independent. I would like you to circle the one that is dependent. In my opinion, it's a lot easier to figure out which one depends on the other one. So circle the one that's dependent, and of course the other one is the independent one. Which one depends on the other one? Seeing most people are done. Mr. M, what do you think on time versus temperature? Which one depends? I agree. This one depends on this one. So this one's dependent, and that one be independent then. Whichever one depends on the other one is dependent, okay? Tell me about the next one. All right. That one depends on the temperature. More than the temperature obviously doesn't care. Ooh, there's lots of ice cream being sold. I better warm up. No. Okay, and then which one depends on the last one? Cost of food. All right, these are the dependent ones, and the independent ones I'll underline. All right, good. So if you were going to graph them, and I just gave you two sets of data, you'd have to figure out where to put it. Then you want to put all the independent ones where? On the X or the Y? Independent ones are the X. Dependent ones are the Y. So this is the Y, this is the Y, this is the Y, and the independent ones, those are the X, X, X. All right, I want everybody to make sure you get that straight, because I just heard 3 wrong answers when I asked for that. So obviously that means a lot of people would have probably said they're wrong. Independent goes with X. All right, moving on. Increasing versus decreasing. It's pretty obvious in these first two here and here which one's increasing and which one's decreasing. Well, as long as you read it from left to right, which we do. We always read the graphs from left to right, just like you always read a textbook from left to right. If you're in China, it's probably more complicated because they don't read necessarily from left to right. If I got it right, I think it's Chinese that goes from right to left, doesn't it? Oh, anyway. I know there's a few languages that go from right to left. I best not guess then. I thought I was right on that, but I'm not hearing anybody confirming it. All right, so if I'm reading from left to right, what's this one doing? Increasing. How about that one? Decreasing. Okay. This one, as I read from left to right, what's it start doing? And then, all right, good. And this spot where it turns, that's considered an inflection point. And how about that last one? Decreasing. Okay. Now, if we're talking about the rate of increase or decrease, you can increase and decrease different ways. I'm going to actually go back to this one for a second, because you guys all agreed that both, the two I'm going to circle here, both this one and this one are both decreasing, but you get that they're doing it at different rates? This one's considered a constant decrease. It's going down at the same rate all the time. This other one is decreasing, yes, but it's decreasing at an increasing rate. What do I mean by that? At the beginning, it isn't decreasing very fast because, see, the slope isn't very steep. By the end, it's decreasing very fast. That's what you always do, is you check the beginning compared to the end, and if it's steeper, it's faster. That's a really important distinction. Steeper means faster. Okay, so this graph isn't decreasing very fast at the beginning, so it starts out slow and ends up fast. Do you get that that's increasing? So it's decreasing at an increasing rate. That's increasing at a what? At a constant rate. This is doing what? Decreasing at a constant rate, okay? At the beginning here, this one increasing or decreasing? In fact, isn't this graph pretty much increasing the whole time? Yeah. Except for a while when it stays flat. When it stays completely flat, if it isn't going up at all, that means it's not increasing or decreasing, it's just called constant. It's like if that's the temperature outside, the temperature remained constant. That's different than constant increase, like an increase at a constant rate. If I just say the word constant, just constant, that means a flat spot in the graph. All right. So now, pretty much other than that one little constant area, it's increasing the whole time. Do you get it's increasing at different rates? Sometimes it's increasing slow and sometimes it's increasing fast. All right. In this little zone here, it's increasing at a what? Increasing or decreasing rate? It's increasing in that zone. Is it increasing at an increasing or is it increasing at a decreasing? Increasing rate at the beginning. And then how about in this little zone here? It's decreasing. It's getting slower and slower. Okay? How would you describe that one? Write it. Like decreasing at a increasing rate or increasing at a decreasing rate or whatever you think it is. And also answer this one. What's that one doing? Is it increasing or decreasing? And at what kind of a rate? Instead of showing me, Mr. M, tell me the first one. What do you think? This one. Decreasing at a increasing. You are correct. Because it's getting faster and faster. That means increasing. Okay, and this other one is increasing at what? Increasing. Raise your hand if you had increasing at increasing on that one. Okay, good. All right, enough said on that one then. The main point of this lesson is that graphs can represent many aspects of real-world situations. You know, growing, there's all kinds of things that can be happening in the real world. Some things are growing, some things are shrinking, some things are not changing at all. Discrete points on a graph versus not, this is an important point. Let me go back to this one. You get how this one had distinct points? That's called discrete. That's a discrete graph. That means that there's nothing in between the points. They're just like individual points. And there's nothing connecting them. Does temperature do that in the real world? Does it go from like 2 degrees to 3 degrees with nothing in between? No, it usually goes to 2.5 degrees in between, right? So that's not discrete. Discrete is more like this. Can you sell 1 can of pop? Yeah. Is there anything between 1 can of pop and 2 cans of pop? No, if you're going to sell cans of pop, that's discrete because you got 1 can and then you got 2 cans and you got nothing in between 1 and 2. You know what I mean? So if you're connecting that with a line, you actually are doing it wrong because there's nothing really in between 1 can and 2 cans of pop. You can draw a line to kind of smooth it out, but it's supposed to have separate things. That's called discrete when you are selling individual cans or selling shirts. Okay, you can't sell 1.5 shirts. You either sell 1 or you sell 2. All right, that's this one. Continuous graphs keep going, and they don't have any little gaps in them or anything. So a continuous graph, this is continuous. Here's one that's not continuous. I'm going along, I stop, and I start up again here, and I keep going. Can that happen in the real world? Yes, but it's weird. Most things are continuous. All right. Linear means straight line. Nonlinear means curvy lines. And independent variable, the independent variable, we just determined this. Was it x or was it y? Independent. X. Independent of the x's. So if you're going to graph it, the independent goes here and the dependent goes here. Get that straight. Okay, next one. Increasing at an increasing rate. They want you to sketch one. Would you make me a little sketch for that, a little sketch for this, and a little sketch for that? Sketch me increasing at a increasing at a decreasing, and increasing at a steady. I think by now you should get those. I want you to zoom in on this one for me. Increasing at a decreasing. When you got all three done, zoom in on that one and turn it my way, and I'll tell you if your sketch is right. Good, 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 good. Nope, that's decreasing. I wanted increasing. You're showing me. Are you showing me steady? Just, good, 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 good. Okay, I'm pretty much seeing it right on everybody's. Increasing has to be like, well, it's three choices. Either this, the black one, or this, the red one, or this, the green one. Is it more black, red, or green if you're doing an increasing at a decreasing? The green one. Good. All right, moving on. I think we've done enough practice of that. You're fine. Let's talk about domain and range. If you're going to get something connected, make sure you get that this is the independent variable, this is the dependent variable, and that the domain is the independent. That's the domain. And range goes here. Domains are like the x's, ranges are like the y's. Another word we sometimes use is input and output. All right. Next thing, if f of x indicates the values of an independent or of a dependent variable y are explicitly defined in terms of the independent variable x by the function f. All right. That's a lot of words. Do you get that f of x is a lot like y? Have you figured that out? F of x and y are kind of the same thing. X is always the input, and this is the output. X's are about your domain, y's are about your range. All right. And if they say x equals 2, then they're really asking you for f of 2. And then really they're asking you to stick in 2 for x. So if x is 2, we stick a 2 right there. And so the answer would be 2 plus 5 is 7. All right. So I'm not going to read all of this to you. If we have a graph here, you've got a 4, 8 being this spot right here. Do you get that one of those is the x and one of those is the y? Therefore, one of those is the input and one of those is the output. Therefore, one of them is a member of the domain and one of them is a member of the range. Are you keeping these all straight? Okay. So if you just say them in the right order, you'll know which one's which. So it's domain, then range. That means x, then y. Independent versus dependent. Input versus output. All right. Take a look at this. F of 6 equals what? Did I tell you the x, the input, the domain, is it a member of the domain that I gave you? Okay, so did I tell you the x or the y? That little 6 is sitting right where the x used to be, right? Isn't f of x the way we say that? So you get how that 6 is sitting where the x used to be? So I told you that x was 6. If I didn't say it that way, if I just said, here, look at this graph. Look where x is 6. Do you get where to look on the graph? Where x is 6. So you go where x is 6. Here's where the x's are. And where the 6 is right there. So I'm going to follow that up, and boom. That spot right there must be the answer. And it's not the x. At this spot, we have 6, 2. Do you get that that's the important spot that goes with that? And if it's f of 6, I've told you that x is 6, and I want to know what the y is. So what was the right answer? F of 6 is 2. Okay, f of 2. Did I tell you x or did I tell you y when I said f of 2? I told you the x. I told you x was what? X is 2. So I find x is 2. I follow it up. Boom. And what do I want you to tell me back? The y. And the y is what? 2. Everybody try to figure out what that next one means then. I'll give you a hint. Figure out f of 0 first. Write down what you think it is. I'll tell you if you're right or not. Turn it my way. Nope. Thank you for trying. Nope. Nope. You're close. Yup. Yup. Nope. Yup. 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 Yep. I know some people haven't showed me yet. It means you're probably confused. Good. Okay. Then, I said to figure out f of 0 first. If you ignore the -3 for a second and just look at the f of 0, do you get that they told me that x is 0? And if they're telling me x is 0, I go right here because that's where 0 is, and I find the spot, and that's the spot, and it's 0, 0. So what's the y? 0. Most of you knew that there was a 0 here, and then a lot of you thought I should take -3 and like add it to 0, and then you got -3 for an answer, but that was wrong. What's happening between the -3 and the f of 0? There's nothing in there, so what do I assume must be in there? A multiplication. That's a multiply. That's why -3 times 0 makes 0. That's why the right answer was 0. Okay? Most of you at least knew that the f of 0 was equal to 0. That's good. But this meant times. -3 times 0 is 0. Okay, moving on. This one's a little more complicated. Figure out f of 9. Then figure out f of 1, and then divide them. That's what that top one means. Fraction bar means divide. Figure it out. Yes, that's right. You're right, sir. Good job. Yep. F of 9 is not 8, but good. I think you were looking at f of 10 was 8. F of 9 is actually right here, and it's 1. So that's a 1 over f of 1 is also 1. 1 over 1 is 1. All right, look at this next one. F of 2 plus 7. In math, aren't you supposed to start with the parentheses? Can we actually do what's in the parentheses there? Yes. So you're just really supposed to do 2 plus 7. And now you got f of what? F of 9. And f of 9 is back to this spot. So what's the answer? 1. Good. The next one. X. Ooh, this one always confuses people. X when f of x equals 8. Now, on all these other ones, they were different. All right, let me double check this and make sure you're doing this right. All right, a lot of you are catching this, which is good. Every answer I've checked so far has been right. Nice work. Yep. Yes. Can you write with a thicker pen? Thanks. Good, good. Good, good. Okay. Yes, everybody's doing this right. I didn't expect you to catch on that quick. They didn't tell you X this time. See? There's still an X there. They told you Y. They're telling you Y is 8. Now you got to go say, oh, Y is 8 is up here. I follow that across. That must be that point. And that point is at 10, comma 8. And I already knew the 8 part, so I needed the 10 part. So the answer is X equals 10. All right, nice job. Now, usually only 2 people can figure out this next one, but your class has been above average so far. Maybe I'll get lucky. Try to figure out that last one there on the bottom. X when f of x minus 2 equals 1. Now give me a second. I got to make sure I know what it is. All right. This one I've seen 4 different answers so far, some of which are right. Some of you are right, some of you are wrong. I want to give you a little more time to think. Some of you are still working on it. Okay, thank you. Thank you. I'm not telling what's right or not. All right. Okay. So, much worse on that one, but it was way more than 2 people had it right. Okay. Let me help you understand this. Did I tell you X or did I tell you Y? I told you Y. I told you Y was 1. So right away you go to Y is 1, and here's where Y is 1, and you follow it across, so that's the important spot, 1, comma 1. I already knew the Y, and so now I just figured out that X is 1. But it doesn't say X is 1. But here's the thing, if this right here is supposed to be a 1, that way f of 1 would equal 1. If this is supposed to be a 1, then what X number would make it turn out to be 1? Yes? You're right. We'll get to that later. We have to do 2 separate answers. But okay. So one thing at a time. Do you get what I said before about how this has to be 1 to make this work? F of 1 is equal to 1. Okay? Because this point 1, 1 right here. So now if this together has to make 1, X has to be 3. You get that? All right. Now, there is another answer for it. So now let's do it for the other answer. Once again, they gave me Y as 1. And as one bright student pointed out, there's more than one spot that touches. There's another spot that touches. So we just do it twice, and there's 2 separate answers. Okay? The other spot where it hits is what comma what right there? 9 comma 1. So that means that this right here needs to be a 9 for this scenario. If that's going to be a 9, how can I make it be a 9 if X was what? 11. So my 2 answers for this are X equals 11 and X equals 3. Now let's see if, now that I've got the answers, if it makes sense to you. If I know X is 11, do you get I'd put an 11 right here, and then that's 11 minus 2 would be 9. Is F of 9 equal to 1? See? F of 9, that's the input, equals 1. And on this spot, if I put in the 3, F of 3 minus 2 is 1. F of 1 equals 1, and that's the spot 1 comma 1. And that works. That's on the graph. All right, that was definitely the hardest part. I'm going to give you one more to see if you're understanding that or not. Some of you want to probably check to see if you're really getting this or not. Because I can see the I'm not sure look on your face. All right. If f of x minus, actually I'm going to make this even a little different. Oh, wait a minute. F of 2x is equal to, hold on, I got to get that keyboard off of there, 8. I want to know what x is. Yes, sir. Yep, good job. You got it. Yep. All four of you. Nope, good try. Yep. Okay. Yep, I'm seeing another, there's one more person had it wrong, so watch. Okay. Don't think this times this needs to equal that. That's the common mistake answer I'm getting. People are thinking that this times this equals that. It's not added at all. Otherwise, you wouldn't even need the graph. We need the graph. So look at it this way. What did I tell you, X or Y? I told you Y. I told you Y was what? I told you Y was 8. Now you find on the graph, where's Y 8? Here's Y. Y's are in here. Y's 8's right there. That's the spot. And what is that spot? What comma what? 10 comma 8. So I already knew the 8 part, so the answer must be the X. And the X is 10. Why isn't the answer 10? Because this thing here together has to make 10. And therefore X must be 5. All right, good. Let's move on. Cool, that's it. Everything you need to know. So, the homework, same spot as it usually is. You got a few minutes to work on this test. If you're gonna, if you had a bunch wrong and you want to get some points back, get a separate sheet of paper out, write corrections on it. We'll staple it to the test. Make a plan to come in sometime this week, do corrections on it. You can get points back. This is going in the grade book, and points back in the grade book are always a good thing. So I'm now going to release your scores into Skyward, and you'll be able to see what it does to your grade. All right, that's all I got for today.